We're well within tolerance, and you can tell that you're concentric all the way through. Now I'm going to put this on here. Boy, that's a low gear mama. And we're going to drill this backwards, because left hand here is right hand for the drill bit. Wait, we can't reverse this drill, can we?
No, we can't.
Oh my God. Well, I have a 3/8 inch chuck on the other drill here. Just barely, but we can do it. Reverse direction, and we just pull her through. That's, of course, after this commercial break and a new battery. We've given you a different camera angle here. We're going to show you some of the things that are really very important to this whole operation, and explain some things that we've done in the past that you shouldn't attempt in the future, especially if you're using our particular tool. This is a mild steel shaft, and it has a bit of a tendency to gall when it's in a relatively soft type of steel, or two steels that have the similar hardness. This bushing is the same stock material and ID of a 2.9-inch bushing that will be the last operation you do structurally on your gear leg. We used to put that bushing in first, bond it in, put the carbon on it, and then do all the back drilling operations, thinking, oh, how slick we were with having this extra long drill guide bushing to make sure that everything was straight. But in doing so, we also had a whole bunch more surface contact area between the shaft and the bushing itself, and it just begged for galling. I still have very good control here of my angles. There's no way this is going to wander. I don't need this extra bit in here. Now when I cut this hole and I reverse the operation, I want to keep this shaft in the middle of this opening. So I'll probably lightly press in one of these bushings to maintain center and lube it up so I don't gall it. But it'll be before final installation of the bushings, and it'll help keep me centered. We'll see if our bits need sharpening, but if it does, it's not a big deal. Yay! That's some chuck we got there. And we're going into carbon already. Seems to be holding up. Wouldn't hurt if we had a wet rag over here. We just wrap it around it and cool it off every so often. Love that chuck. Going off real good. We'll be back with you in a minute. All right, we're back. Sharpened the bit a little bit. It pierces through the carbon fiber. Can't hear it now, but it was hot. Keep her cool. Blade still feels pretty sharp. Oh yes. There's that lovely chuck again. You can see what our operation is going to look like. I'm into phenolic now. I'll show you what it looks like on the inside. It's going to be a bit of a pain in the buns here to finish this, but how's that look? You see it, Chris?
Got it.
We'll finish drilling that, drop the bushing into the opposite side to guide on the opposing cut, and we'll show you what it looks like when we're finished. This is the bushing here. To say the very least, it's a very tight fit. And with this being as tight as it is, we'll end up sanding the perimeter and cleaning it up, and probably using the bearing potting compound that Loctite makes. And it's not dependent so much on anything other than the close fit, so the press would be more than sufficient, but the potting compound does an excellent job of bonding in place and taking up any other irregularities that you'll find in a fibrous material. We've finished drilling. We actually did something we weren't going to tell you about. We had about 90% of this whole board, and it was pretty close. We had all the way up to this last layer of phenolic. And we realized that we had created a situation where we could use a much simpler device to finish up removing the meat. But we still had the guiding ability of the perimeter of this 9/16 inch hole to provide a continuing pilot for the rest of the cut after we had removed, and very quickly I might say, about 3 seconds worth. And the drill pulled itself right through. And then we followed up by yanking this through, which took us maybe another 10 seconds. But you have to be very careful when you're dealing with a 1/2 inch drill in a 3/8 inch hole with that kind of power and that kind of sharpness. It will destroy the material as you go through. You have to go through very carefully. Now, we've chamfered the end of this bushing.
Hang on. Got it.
So that as it goes in, it doesn't bite material and shave as it goes through. It fits very tightly. Slide into it a little ways, make sure that it stays absolutely in line with the way it was. Oh yeah, sure, Dave. That is the way it should fit. It is tight. If it fits loose, that is as yet still not a big deal, because you'll just sand the exterior and pot it in place with epoxy. With this kind of tightness, there's only one thing I need to be concerned with. Composites are hygroscopic. They will hold some moisture, which means I want to treat the outside of this bushing with something to prevent it from rusting between the composite material and the bushing itself. The Loctite potting compound that I referred to would be perfect for that. It bonds beautifully to steel, would prevent it from corroding on its exterior surfaces. You can put a light grease on the shaft bolt when you install it. These will be CAD plated in the future, but at present they are not. So that's how you handle a corrosion problem in an area that you can't get to. I'm going to slide this out of here and give it a little bump because I need to treat this bushing yet. Sand its exterior, cover it out. You can also use West Systems epoxy or safety epoxy for the inside of the hole before installing this, covering the bushing. That will work just beautifully, and the safety epoxy would act a bit as a lubricant as you install. You have a number of different options. If I simply pressed it in place, it would be more than sufficient to handle what we're doing. It doesn't need to be bonded in place. We'll be back to you as we finish up that last operation. Okay, we're going to repeat the operation we did before with one minor hitch. As the bushing we showed you installing before, we've pressed in about halfway, made sure that it didn't bind. I very carefully applied a little bit of WD-40, you can use any lubricant you want, to this shaft and made sure that it went inside the bushing so that you don't gall the bushing. It's this soft shaft here that I'm using. It's the real culprit. That keeps things absolutely lined up. There's nothing else different about this operation. I have all the same limitations and problems I had before. You can occasionally sharpen the bit as needed and proceed as you did before. Back with you when we get ready to do the final installation of the bushings. Okay, you've seen this resin coating operation. I'm using West, Old West, by the way. It's the raspberry color. I'm just wetting the inside of the bushing holes. Make sure I'm completely coated on the interior. As I mentioned before, this resin is not really here to do the bonding job. It's more to make sure that the bushing is sealed on its perimeter surfaces so that they don't corrode more than anything else. But while we're at it, if we're going to bond, we might as well do the best job we can. If you thought you got any lubricant on the surfaces of the inside of these bushing holes, I hope you washed them out with lacquer thinner or MEK and just be absolutely certain there was no residual lubricant left. Now, if you feel particularly sloppy or are considered sloppy and you can't control yourself that way, don't use WD-40, because if you get it on the surfaces, you'll never get all of it off. WD-40 has silicone in it, or so I've been told, and I do know that about silicone. Hard to get off. Okay, now, I didn't use a brush. This doesn't really warrant a brush. Just going to smear the bushings exterior. I just sanded these moments ago. Did I mention it's been beveled on one edge, Chris? Okay, yeah, I beveled one edge so that it doesn't grab as it's going in. You can see how that first section goes in pretty smoothly right there. Now I'm going to put both bushings in at the same time for the purposes of alignment. I'm going to run that same shaft, the one that used to have the drill bit on the end. You didn't see the last portion of my tape. I was using it incorrectly, and I broke the drill bit off the end. So now we're going to use it as a guiding shaft. Put these things in place. Any 3/8 inch shaft would do. Help guide it in place. There's my bevel edge. Put it in. Make sure I don't have any resin inside the tube. This is where the bit was, so I'm not going to smack this end first. I'm going to go in from here. Get in a little bit. There's the tube to the other side. Some of this one. Go right up flush with that. I'm reluctant to use a hard hammer because it can mushroom the end of the bushing. I'm within 10 or so thousandths of this edge. I'll show you. With the bushing, very close. If I tap this in the rest of the way on this end, I'll be flush on the opposing side. I'll find a piece of aluminum or phenolic to place against here to give it its final smack so I don't mushroom the head. I'm going to reverse this whole process, wiping the epoxy off the surface here. Back a little ways so it's not hitting on it. Here we go, folks. Bushings are in. Wipe up our mess. Get the epoxy out of the inside of the bushing if there is any. And here's how she looks. Both sides. More resin. Now I'll give it a smack with a block of phenolic or some aluminum and back with you in a moment. Okay, mission accomplished. The phenolic and aluminum block didn't work. Sucked up too much energy. I had to smack it with a steel hammer, but it moved did not mush him out the hole. And the result is push it through. If that works, you've got to be happy. That should be the results of your efforts. I have a little slop on each end, but there's no load borne on this part in this direction. When I drop my bushing on the inside, and if I want to decrease my tolerances some, I can do it then. But that is a completely superfluous requirement. You don't need to do that with any of the things that you're doing. Now, if you have a little misalignment here, and it requires a little work to get to go in, don't worry about it. Work out just fine. Okay, we're going to do one last operation before we start the MG30 installation. We're going to loosen up the bolts that we set up last night. The flux pad. See how this all works. See how much epoxy we managed to get on our threads. I'm going to remove all these bolts, but I'm not going to do so on tape. We'll be back with you in just a moment. This isn't really showing good form. We really should use an 1/8 or 3/16 inch drift on this bolt. It's conceivable that we can consider these bolts mock-ups anyway. Now, I'm being rather carefree about this axle. But this is one of Ronneberg's pre-crashed parts, so not a great deal of concern for that part. But it came through all right. I'm going to remove the others, and I would encourage you to use the appropriate tool for its removal. We soaped these. The soap worked. You can see the materials coming off of here very easily. It looks as though the threads had been uncompromised. It does thread on, so we didn't damage the bolt, but I think a drift would be a much better idea. Back with you in a bit. All bolts removed fairly easily, no damage to any bolts, and this just about fell off. Perfect fit. I'll take a beveling tool and remove a little bit of epoxy from these edges. I'll grind this flush. It needn't be here at all. And that's really all that's necessary to be done to this face to complete this portion of the operation. We're going to go on to the MG30 installation until we receive our bushings in the mail, and we can go on with that portion of the process. But that's how it should look. A nice transition from this surface to this. Well supported. Thank you very much. All right, here's our MG30s. You have two of them. This is the bagged back side of the right and the left MG30. This is the right MG30. The scribe line is done off of a 1/4 inch thick aluminum plate, match drilled, and all you've got to do is attempt to cut, since it is a groove, cut halfway into that line and leave the inboard surface of the mark. Just do something like that on the rest of it. You can actually see the remainder of the scribe line on the inside edge. You've heard of the theory: measure with micrometer, mark with chalk, cut with axe. Well, reverse the idiom. You know, measure with micrometer, mark with scribe, cut with ultra thin blade with ultra caution. Keep them the same. These were templated for a purpose to control the assembly process and the fit. maintain your accuracy here, and everything will go together, and you'll end up with a gear installation that will be surprisingly simple and easy. Thank you. Okay, we've trimmed his MG30s. Now, you might notice a ragged edge here in the bottom. Wayne here has an unusual machine in that his fuselage core is half-inch thick, and yours is 3/8. All of yours are 3/8, all of you but Mackie Chapman. And let's see, a gentleman in Malta. And if you have quarter-inch fuselages, you want to leave an 1/8 inch more material on. If you have a half-inch fuselage, you want to take an 1/8 of an inch more off. But 99.9% of all production airplanes out there are 3/8 and don't change anything. Go cut right to the line. 3 bolts. They go this C-section facing aft, this C-section facing forward. You can tell by the joggle on the bolt line and this bolt line. That's how it's going to go. They'll only go one way. We're going to take this, put it on top, and the bolts all through. We're going to run 2 bolts per position. This is my mock-up set of bolts. We'll be back with you in a moment. Hello again. You need 4 circlips and 4 bearings, KP8s, and you need 4 of these little top hat bushings you see here that step the bearing out. The bearing drops in so. These are extremely close tolerance. I could probably push this one in with a little bit of effort. But the CAD Type 2 hard black anodized is hard enough to shave the CAD plating off the bearing, and I don't want the bearing to fit in there that tightly. I might jock it in place and have to bang on it. So I'm going to go stick the bearings, all 4 of them, into the fridge. And I'm going to put these in the oven and bring them up to about a couple hundred degrees. And then bring them all together, and the bearings will drop in place at that stage. And after they're fully seated against the opposing sides, then we'll take a circlip tool, put the circlip in place, goes into the slot here, put them in. After having done so, we'll take these and put them in their appropriate places. This is the left rear, and we'll check to see if all the bolts fit. And as we do the fitting, we'll do any cross-reaming necessary to make them made up as they're supposed to. And the discrepancies will be very minor. Don't be afraid of reaming to fit. More than likely, the phenolic and this aluminum will move, and because of the hard anodizing, this will be compromised very little. And we'll be back to you as we put all this stuff together after it's been chilled and heated. Okay, we have the parts in the oven and some in the deep freeze. We're going to show you some sanding prep. We're going to go about 1.25 inches here at the back. I'm sorry, brain dead. That should be on the inside surface only, about 1.25 inches forward. That'll be left and right side. And then down the bottom inside, you've got about 1.25 inches or so. Both sides. We're not going to do much taping on the interior surfaces. There's going to be 4-ply that run from here along the bottom of the fuselage and back up the other side. This whole face we're going to sand, every square inch of it. So it's the bottom and the back on the inboard surfaces that get just a minor amount of sanding, and the entire outboard surfaces. We'll do that prep while our parts are chilling. Welcome to the Aeronzi kitchen. Presently, we have 4 special little items cooking here. Oh, they look ready. I'll grab one out of the oven onto the table. It's quite warm. Shouldn't take much. Here we go. We get close up?
Yeah.
Go, baby, go! Bang! Hot! Right into the surface. Now, I'm going to go do one at a time. I'm only going to embarrass you with one. And there we are. You notice how this bearing is well below the surface? And it's because of the wall thickness of the aluminum here to handle the thrust load. Put our step bushing that go in there, the shouldered bushing. We'll take care of that handily, and we'll be back with you downstairs to show you the final installation of the MG30 bracketry, back drilling, and such. Okay, I've got 3 of the remaining 4 bushings here. This one's already in place. You can see it sticking just through. It fleshes this out so that when you go to put your gear leg in, it's sitting on top of the bushing and not the race for the bearing is well inside. That's verboten. So here's the way it's supposed to go. Circlip is in place. Let me show you putting a circlip in. It's lots of fun without circlip pliers. Here's the new circlip pliers. Just happen to be a very fine-tipped set of needle nose. First thing is check the bearing. The bearing's nested all the way in. We had one recalcitrant one that heated up while it was sitting in the... Yes, sir. Got one half of it in. It wouldn't hurt to file these, but I don't own them. There we go. Bingo. Dropped in place, snug. Finish them all that way, and then we're going to bolt all this pre-sanded stuff together and drop a gear leg in place. Finish cutting out the side of the holes in the fuselage. And then we'll show you where the appropriate sanding inside the fuselage must occur to mate these in place. Here on the tabs for the last important structural consideration on this gear leg. Make your bolt, make sure it goes through just fine. And you now have your bushing 3/8 ID, half-inch OD, 2.9 inches in length, chrome moly steel. And make sure that it fits okay on the bolt. What we're going to do here, I'm going to show you how all this stuff relates. I'll come from the other side here again. You still in frame, Chris?
Yes.
Come on. In an effort to maintain a camera angle for you folks, I'm looking like the proverbial monkey screwing a football. You notice how that sits right there? We're going to sand the area directly beneath this. I'm going to mark that area, and I'm going to sand all the way down to here. From there. Go considerably wider than just this width, because once you've done your layup process and put your bushings and all that stuff, you can use those opportunities, those sanded areas adjacent to these things to do fill material, because you're going to fill this whole gear leg eventually, so that you really clean it up cosmetically, so it's always easy to clean later on after you've painted it. So we're going to sand all the way to here. We're going to sand to 1 foot. 10 inches below this point. So it's 7 inches or so from the bolt center this direction, 10 inches below to this point here. We're going to cut 8 plies of carbon fiber that run from this point to 10 inches below. So they're going to start off 17 inches in length, the first ones, and taper 1.5 inches per ply, 8 plies. I haven't got that figured out, but I'll give you that sequence in a moment or so. So again, 10 inches below, that's to here, and up to here, straight line on either side, 8 plies, 1.5 plies. Speak, you can talk.
Flocks underneath.
Flock. The first thing we're going to do, after we've done all this sanding, is I'm going to sand this bushing carefully and just put a cursory layer of flocks underneath, just enough to make sure that it sits still and hardens in place. When it's in place and the resin's 80 or so percent cured, then zip, we pull this bolt out of here, leaving the bushing floating in space, and we're going to pot flocks from this surface down to this surface in both directions. Let that cure, sand it, and then we'll run the plies of carbon fiber. 1/2 inch per ply on this side, shortening, 1 inch per ply on this side, shortening, until we're equidistant to the bushing. Back with you for the next process. Okay, we've sanded this very well. Got the bushing on here. Notice the bushing is very well sanded. You sanded it with gloves on so you didn't transfer body oil to anything. We've got it protected so that this thing is fitting in here. The bushing is somewhat in the middle. I don't have to have this in place, obviously. And for the sake of not slopping and slathering too much surface area, we can stick some more silver tape in place here. Then we're going to brush this area with a little bit of fresh resin. And then I'm going to brush just a little bit of fresh resin on the bottom of this tube. I think you probably see that, can't you?
There is mold release on the bolt.
Yes, there is mold release on the bolt. Okay, resin down. Final check. We're good. Now we're going to take some pretty dry flocks, something that isn't going to move around much, and we're going to pack it in there. Underneath. Doesn't have to be a very big area. I'll do this from both sides. The bottom of it, the base of it, will be about 1 inch wide, and of course it'll be this direction. So we get that packed in, we let it cure, and once it's cured enough, then we'll pull the bolt and do the next operation. Back with you then. Allow this to cure, check the fit of the shaft, goes right on through, check again the placement of the associated parts. Sing. I'm going to remove all the gloss from here. I'm going to remove any print from plastic tape and sand this area judiciously. Then I'm going to take something flat, like this. And I'm going to place it on top of the bushing with silver tape underneath it. And it's going to sit on top of the most logical place here for a straight transition from the top of this bushing onto this surface. So as you can see that, just essentially like so. Make a flat. And I'm going to do the same thing from the opposing side, and it does that very nicely. I'll probably go to a point about right here. And one piece there, one piece there. Allow to cure. It will be regular 2410, 2183, 84, 87, or the new PKMW, depending on where you are with your particular kit. So my next step, I'll be back with you in a moment. Well, we've done this. We've done the re-sanding of the area, cleaned it up, got rid of all of the gloss, got rid of all of the gloss. He said, yes, he did, and made sure that everything fit. And I had a chance to rethink this, since what I want to do, I want to do this process all in one shot. I was showing you this before, thinking, yeah, we can do that. Well, we can do that if I have the time to want to wait for this one to cure, and then want to put that one on, let that one to cure. I don't want to do that. So what I'm going to do is I've mixed up 7 shots of resin here. I've got quite a bit of flocks here to do. I'm only going to do one of them at the moment. I'm going to smear some resin on this surface, and after I've done that, I'm not going to get the brush out for this operation. I'm going to smear it out about as far as I think I'm going to end up going here, which would be about right here. I took some flashing material, which you can get in steel or aluminum. The stuff I got is aluminum in the hardware store. Now I've bent up a piece of it that I'll put right here. Now you can tell how much resin I need to make sure I cover everything. That'll do that job. For the opposing side, do the same thing. Mix the rest of the resin up to a relatively dry mix of flocks, something that isn't going to move, isn't going to flow out from underneath this. Get a good attachment, plenty of resin on the surfaces. I've got a really good bond to that tube. You can tell by the way it feathers. Now I'll be back with you in a moment after I get the flocks mixed. Okay, we got the flocks mixed up. Fairly firm. And it ain't moving around. The idea is pack it on in a fashion that ensures that you do not have air underneath it. Now I just rolled up some saran wrap into a ball and stuck it into each end of the tube, so I'm unlikely to pack the end of the tube as well. I'll try hard, but I won't succeed. I want this tube completely, totally supported wherever I can get the stuff to match. Down here on the ends. Oops. I failed to coat that with resin. As I mentioned before, this was 7 shots of resin. I'll make sure I don't have gaps. Now that I've got it spread out, I'll pack it up high here, like so. Get it in the center here.
You don't want clamps for the sheet metal?
No. See, sheet metal is just going to sit in place. The sheet metal doesn't weigh anything. It doesn't. It has to fit very well in and of its own accord. Now we may not get this flux fill absolutely perfect the first time, but we'll have 99.9%, at least to the extent that we know it is not going to require a rework. What I mean by that is that if it's not perfect, it's not going to matter, because it will be close enough that all I have to do is fill small holes with a subsequent layer of flocks. And but that will not force me to wait for another cure, because the holes in the fill will be so small as to just do a wet layup right over top of it, and it won't have any negative effect on the straightness of the fibers. And that's why we're going through all this. Why don't you just do this, shape this stuff and put the cloth on top of it, because the flocks would move like crazy. And the strength here depends on the straightness of the fibers. That is absolutely paramount. I push down on the bushing and I shift this end back and forth until I get an equal amount of squeeze out of both sides. You have to make more resin than you need to make this work.
Angling those sides, or are you...
Just slightly, just slightly.
Okay. And there's mold release on the aluminum?
Not in this case, no. It's been laying around for a long time. I won't get a bond to it. Now, it wouldn't hurt to make this aluminum just a hair undersized at 2.9 wide. I made mine slightly oversized. I shouldn't have done that. I'm going to push it back in there. Because if you make it slightly undersized, you can really clean up to the edge of the bushing and save yourself a lot of work in the long run. So, I'm going to push that out of there like that. The sounds of Dallas at night. Okay, that's what it's going to look like. And you're all done. Flocks in both sides. And if the flocks is dry enough, it'll be very stable. Anything that got resin on it, like this, we're going to oven cure this tonight. I want it rock solid tomorrow. You know, it's a little lumpy. I'll sand those lumps out and get it as straight as I can get it.